What if you could tell your computer exactly what to do, down to the tiniest detail? Well, today we're going to crack open the language that makes it all happen, C++. We're going to build out your very first coder's toolkit.
You know that feeling of having an idea and then actually bringing it to life on a screen? That right there, that's the magic of programming. It's all about taking that cool vision in your head and turning it into a set of instructions a computer can actually understand and follow perfectly.
And C++ is the language we're going to use to have that chat. But here's how I want you to think about it. Don't get hung up on learning a language. Instead, imagine we're just gathering up some Lego bricks, the essential building blocks to construct literally anything you can dream up.
Right, so just like you wouldn't start building a house without a blueprint, you can't just start writing a program without a solid foundation. And in C++, that foundation has a super specific, totally mandatory structure.
We call this the code skeleton. And let me be clear, this isn't a suggestion, it's the absolute bare-bones minimum you need to get a C++ program to even think about running. It is the non-negotiable starting point for every single thing you're ever going to write.
So let's break this blueprint down. Include is like telling your program, hey, go grab my toolkits from the truck. You're pulling in pre-built libraries of code. Then you have int main. That's the front door. It's where everything officially kicks off. The curly braces, think of those as the walls of your house. All your instructions, all the action, happens inside them. And return 0, that's just you giving the computer a thumbs up, saying, all good, mission accomplished.
And hey, here is an awesome shortcut for that blueprint. Seriously, this will save you so much time. Instead of grabbing different libraries for math and for text and for whatever else one by one, you can just use this one single line. It's like having a master key that unlocks every single toolshed on the construction site all at once. Super handy.
Okay, so the blueprint is down. Now, what are we building with? In the world of programming, our building materials are, well, they're data.
But here's the thing. Not all data is the same. A data type is basically a label that tells the computer what kind of material you're handing it. Are we working with bricks, wood, maybe glass? You wouldn't build a window out of concrete, right? And you wouldn't use a number to store someone's name. Every material has a specific job.
So here are some of the most common materials you'll be using. Int is your go-to for regular old whole numbers, like 10 or -5. But what if you're dealing with, like, a massive number? That's when you bring in long. For anything with a decimal point, like 5.6, you'll want to use a double. String is for any kind of text, like hello strivers, and a char, that's for just one single character, like the letter G. Choosing the right material is absolutely key for writing good code.
All right, so we've got our blueprint, we've got our materials. Now it's time for the really fun part, the tools, the things that let us actually build something smart, something that can think.
Okay, the most basic, fundamental tool in any programmer's kit is the power to make decisions. That's what the if-else statement is all about. It lets your program react to different situations. It's literally a fork in the road for your code. If this thing is true, go down this path. Else, if it's not, go down this other path. This is how your code starts to get a brain of its own.
And here's a perfect real-world example of that. Let's say a program is grading papers. It can use an if statement to check the score. If the marks are below 25, the program decides the grade is an F. It's such a simple piece of logic, but it is unbelievably powerful.
Making one decision is cool and all, but what if you have to grade 500 students? Or say welcome to every single person who logs into your website? You're not seriously going to write the same line of code 500 times, are you?
No way, of course not. That is exactly what loops are for. A loop is your personal little robot assistant. It takes a bunch of instructions and just repeats them over and over as many times as you want. It's a massive time saver. Loops are all about working smarter, not harder.
The for loop is a total classic, and it's like a little engine that you can totally customize. It's got 3 main parts. First, you initialize it, which is like turning the key to start the engine. Then, you set a condition to tell it when to stop. And finally, you have an increment, which is what keeps it chugging along, cycle after cycle. It gives you super precise control over exactly how many times you want to do something.
Okay, so now we know how to make decisions and how to repeat tasks. Let's talk about the ultimate way to work smarter, creating little pre-built components that you can just reuse whenever you want.
And that's what a function is. The best way to think about it is like a recipe, right? You write the recipe for, baking a chocolate cake.
You give that recipe a name like make chocolate cake, and then anytime you want a chocolate cake, you just call that recipe. You don't have to write out all the steps every single time. It's brilliant.
But this brings up a really, really important question. When you give your recipe, your function, some ingredients, some data to work with, what is it actually getting? Does it get the original bag of flour or just a scoop from it?
And this slide just nails the explanation. The default way is called pass by value. I want you to think of this as making a photocopy of your data and giving that to the function. The function can draw all over it, rip it up, do whatever it wants to that copy. But your original document, it's perfectly safe, untouched. Pass by reference, though, that's like handing over the actual original document. Any little change the function makes is permanent. Understanding this difference is so important.
Now, like with any good rule, there's a big exception in C++. Arrays. You know, those lists of similar data? They are always passed by reference. There's no photocopy option. So if you give a function an array and it changes something in it, it's changing your original array. End of story. That's a huge detail you gotta remember.
Okay, as we wrap things up here, I want to leave you with this amazing piece of advice. It is so easy when you're starting out to get completely overwhelmed, to feel like you have to know every single tiny detail. But listen, the key is to just focus on the basics first. Get your foundation solid. The deeper, more complex stuff, that'll come with time, with practice. Seriously, don't be afraid to just jump in, experiment, and make mistakes. That's literally how you learn.
So there you have it. We've gone over the blueprint, the materials, and the tools. You now have the fundamental building blocks to create pretty much anything you can imagine. So the only real question left is, what are you going to build first? Thanks for joining me on this one, and I honestly can't wait to see what you create.